Okay, so what I want to start with is taking a look at the general form. Whoa, hold on. Okay, there's a little bit of feedback there. All right, so I wanted to take a look at emphasizing and kind of cementing in this idea of this new function. Right, we got a chance to do that through Desmos to introduce to you the different types of transformations and the way that the function can behave. Right, those are all the different possibilities of it, and we looked at certain reflections over the x-axis and the y-axis. We looked at what we call dilations, where you were stretching the function or compressing the function. And then we looked at how you can shift it, left, right, up, down, and then each one of them is controlled by a certain part of the function, right? So A controls certain things, H controls certain things, and K controls certain things, right? And when you put it all together, it allows you to shift, reflect, dilate the function anywhere along the XY plane, all right? So what I wanted for you to look at today is the general form of the function that we will be seeing. And this is going to be pretty familiar because it's going to come up pretty often in other functions. You'll see the same kind of letters or the same kind of variables, placeholders. So what we're used to in like, before we get to algebra 2 is kind of this function, right? But not really seeing it in function notation. So when you see there the general form, it starts with y equals a times absolute value of x minus h plus k. That's what we saw on Desmos, right? Now, the only difference is that as we move forward, we're going to start to look at things in like function notation. So instead of y, you'll have f of x. So what I mean is like just being able to see the difference, right? Where this part of the function will literally be function notation. So you have f of x instead of y, right? But we know that these two mean the same thing, right? Y is an output, f of x is an output, okay? That's really the only difference, okay? Now, the other thing is, because we're gonna graph them by hand today, is to identify the most important part of the graph, which is the vertex, right? And I put the definition there for us, is that the vertex is either the highest or the lowest point of the function, right? Remember that it's a V shape, right? So in one direction, it'll move forever, right? Depending on which way it's pointing. So the vertex only exists in one place. It's either the highest or the lowest. So if I have a V shape that's pointing up, right, I have no maximum because these two are gonna keep going forever. But if I have a V shape moving down, then I have no minimum because they keep going downward forever. So depending on the shape, you're either gonna have a maximum or a minimum, but not both, right? So we just have to look to see what is the shape and then identify, is this gonna have a min or a max, all right? And that's where our vertex will be, right? And the vertex is important because not only is it the highest or lowest, typically that's where the symmetry happens on an absolute value function. The same way that symmetry occurs in parabolas, absolute value functions have symmetry because you can cut the graph down the middle and you'll have symmetric sides, right? And then the other thing is, how do you identify the vertex, all right? Well, the vertex is found looking at h and k, right? H and k are the two values that we will use to create the vertex or to find where the vertex is. And then one of the ways that I like to remember it is opposite keep, right? Because we know that H moves in the opposite direction, right? So when you shift it, when you moved H, like if you were adding a number, it was actually shifting to the left. If you were subtracting a number, then it shifted to the right. So then we have to think, okay, if I want that H value, it's actually the opposite. And then for K, we keep it because that one was moving in the direction that it should have. If you add a number, it shifts up. If you subtract a number, it shifts down. All right. So that's kind of the introduction into everything right now. Okay. So the first thing I want to do is I want to graph the parent function. And we kind of saw this over and over in Desmos. Okay. But I want to formalize it. Right, and discuss what the parent function is. Right, so the parent function is simply y equals, or in this case, I'm going to use f of x. F of x is equal to the absolute value of x. Right? It is the parent function. It is the original absolute value function where no transformations have occurred to it. There's no dilations, no reflections, no translations, nothing. Okay. So let's say I want to find the vertex for this parent function. Right now, you might remember what it is by looking at a graph, right? But another way to think about it is, think of this function, right, as having some placeholders, right? Because right now, we want to find the vertex. We want to find h and k, but I don't see any number inside the absolute value, and I don't see any number outside the absolute value. Okay? Would you agree that f of x is equal to absolute value of x is the same thing as f of x equal to absolute value of x minus 0, and then plus 0 on the outside? Would you agree that those two are the same? Yeah, right? I'm subtracting nothing from the inside, and then I'm adding nothing to the outside. So I'm not shifting in any direction, right? Like move 0 to the left. Okay. Move 0 to the right, and then move 0 up. Well, you're not going to move at all. Okay. Why does that help us though? Because it helps us see where the vertex for this function comes from. Because now I can see, well, my h typically goes here, and my k typically goes here, right? So then in order to find the vertex, what I look for is, okay, well, it wants to be opposite of the inside number, and then keep the outside number. Right? Opposite keep, that's where that comes from. So then my vertex, well, the opposite of negative 0 is just 0, right? There's no opposite of that because it's just 0. And then keep 0. So then, hey, my vertex actually shows up as 0, 0, which is the origin. All right, so those are the locations that I will look for if I'm looking for the vertex. Inside the absolute value, I will always take the opposite of that number. And then the outside, I will always keep that number. And that'll tell me exactly where my vertex is at, right? Because this is h, and then this is k. Right, so now that we know where that comes from, we're going to build a table. And like I said, I'm going to show you how to do the graph using a table the first few times, but then after that, we're going to move on to something more sophisticated. All right. So right now you just have an xy, or actually you could use x and f of x, since we're trying to keep the f of x notation. Right. And this part is pretty simple, right? We're just going to build a table of values. Repeat. Okay, are we talking about the h and k part, the opposite keep? Okay, so right now I rewrote f of x equals absolute value of x. I rewrote this part into this because I wanted to show you why the vertex is 0, 0, right? It's built into the function. It's just kind of like invisible because when you subtract 0, there's no need to show that. And when you add 0, there's no need to show that either. So the reason why I rewrote it in the new way is to show you where the vertex comes from, that the vertex will be HK or opposite keep. So you will always, in this part right here, you will always use opposite of what that number is. Right now it's negative 0, so there's no opposite to that, right? It's just 0. But sometimes we'll have like negative 2. And so you'll take the opposite of that number. So that means that your vertex will start at 2, right? The x value will be 2. And then you will keep the outside number. This always stays the same. And then you use those two numbers to create the vertex like I did right here. Right? So that's why my vertex is 0, 0. Okay. Does that make a little more sense? All right. Okay. So then when we're building a table now, all right, remember a vertex tells us where the two lines of the V shape connect, right? It also tells us the minimum or the maximum point, and it tells us like this is where the symmetry occurs. So then because I know that there is symmetry in this graph, I like to put my vertex in the middle, right? So what I mean in the middle is I have a table here, and instead of putting my vertex as the first set of numbers here, I like to put them in the middle of the table, meaning I'm going to put it here and here. And I'm going to label this with a V, knowing that, hey, those are my vertex points. Okay, 0 is the input, 0 is the output. So then in order to determine a few more values to be able to graph this, I just need a couple of inputs that are a little bit less than 0 and a little bit more than 0, right? So if I'm looking for values, inputs that are a little bit more than 0, I'm just going to pick 1 and 2. And then on the other side of 0 would be my negative values. So I would pick -1 and -2. So when you build a table, right, you want to build around the center. So you put the center first, and then you pick 2 numbers to the left of that, and then 2 numbers to the right of that. So that's why I picked -1, -2, 1, and 2. Okay, so they're easy numbers to deal with as well. All right. Okay, so now to find the output, it's pretty simple. This is just where you plug things in. All right, how do you do that? Well, since this is the x value, you're going to take that, you're going to plug it into the absolute value. Right, so it's basically like saying, what is the absolute value of -2? And we know that this is just +2. We do the same thing for the next x value, right? So now we take -1, plug it into the absolute value function. So -1, absolute value of -1 is just 1. All right, same thing with the other 2 values. These are pretty easy. Absolute value of 1 is just 1. And then absolute value of 2 is just 2. All right. So I have created now my inputs and outputs, right? I like to then translate them into coordinate points, because then I can just look at my coordinate points and I know what I need to graph. All right. So for this one, the coordinate would be -2, 2. For the next one, -1, 1. This one was already done for us, right? There was no need to do it because we knew what the vertex was already, 0, 0. Then we have 1, 1, and then 2, 2. Right? So here are my inputs. Those are my x values. Those are my outputs. Those are my y values. All right. So now that I have the table and I have my inputs and outputs, I have my coordinate points, then we can just graph it, right? We can just graph it on an XY plane. All right, so let's go ahead and do that. All right. So using red here, so it stands out a bit. The first point I always like to draw is the vertex. All right, I like drawing the vertex first, and I like labeling it. Right, here it is. It's my V at 0, 0. Let me zoom in a bit. Okay, and then I'm going to plot everything else. Right, so -1, -2. This would be 1. This would be 2. All right, going upwards, that's 1. That's 2. So let me plot my points. I have -2, +2. I have -1, +1. 0, 0 is already plotted. Then I have 1, 1. And then I have 2, 2. Right? So you can see that my dots there, my points, have created that V kind of outline, right? So then all that's left for us to do is to draw the correct shape. The reason why I like labeling the V is because it tells me where to start drawing my line, right? So if I started at 0, 0, then I know I just draw the line connecting those 2 other points moving outwards, right? The V moves through the points, okay? And then the same thing occurs on the other side, right? So I start at V, vertex, and then I move through my points to create the shape, right? So there's my absolute value function right there. All right, notice how I have arrows on the tops of the function or on the top of the line because the absolute value function doesn't stop. You guys saw this on Desmos where the line keeps going forever. You keep zooming out and the function just keeps going. So those arrows are necessary. They are necessary, absolutely necessary, because it indicates that the function continues, right? Just because we don't have the paper, we're not going to draw it forever. It doesn't mean it stops. So the arrows on the tops need to be drawn, all right? So these little guys right here. Okay, so not too bad, right? Pretty easy using the table of values, but of course it takes a while, right? Like you build the table and then you got to apply it, right? So it's kind of slow. It's a slow process, right? So that's why I'm going to show you the the shortcut in a minute for the next example. The difference between this and a parabola is that the parabola is an entirely separate shape. A parabola is a very unique, it's a very unique shape. So a absolute value graph is a straight line. Literally, it's like linear in one direction and then linear in another direction. There is no curve versus a parabola curves, right? And we'll take a look at that. And also the function. The function is entirely different too, because with a function, with a parabola, it's a quadratic. So it's you're squaring numbers. Okay, so a parabola will actually grow much faster than an absolute value function, because when you're squaring something, typically that number grows much faster. Okay, so that's key. I'm glad you brought that up, because a parabola should be curved and an absolute value should be straight lines, making a V shape. Okay, so at least visually on a graph, that's the big difference. All right, any other questions so far? How are we doing? Not too bad, right? Pretty easy. Pretty good. Okay. All right. Now, the last thing I want to discuss is the concept of domain and range, right? And it's a little bit tricky to kind of talk about and describe here over, distance, because usually I like to describe domain in like hand symbols and like signals. All right, but let's kind of see if we can get a good idea of what it means. All right. So if I wanted to discuss domain and range, domain is another way of saying like, what are all the possible inputs, right? Like what are all the values that I could use to plug into the function? And in this case, the function is just absolute value of x. Like what numbers could I plug in? Well, we have a table that shows us we can plug in like -2, -1, 0, 1, and 2, but those are not the only ones I can plug in, right? So then one way to think of domain is like, look at the graph, right? Look at the graph and try to understand what the graph is saying. The domain is talking about all of the possible x values, right? All of the different x values. So think about it. If I follow the direction along the x-axis, right? Like how much of that graph does it cover? How far left does it go? And how far right does the graph go? And that's going to tell me what the domain is allowed to be, right? So think of it that way. Domain means how far left does my function go? How far right, right? So if you see that the function moves to the left and there's an arrow, it is moving up, but it's also moving to the left, right? So I'm talking about this part right here, right? It's moving up, but it's also moving left, right? Since it's an arrow on the top, it's gonna move in that direction forever. So it goes left forever. And if it goes left forever, where is it gonna reach? Infinity, but it's moving to the left. So it's actually gonna go towards negative infinity, right? So you wanna think of it like a number line, right? The number lines that we did with inequalities. How far left does the graph go? It goes to the left forever, therefore negative infinity. So my domain is gonna say, well, it starts at negative infinity. Sorry, let me do that better. And then now we look at the other side of the graph and try to find out how far right does it go. Right, just look at it almost like which way is it going on the right. It's going up, but I don't care about it going up. It's just moving to the right. So if it's moving to the right forever, those are the positive values. It goes to positive infinity. All right. So then my domain is telling me from negative infinity to positive infinity. And we know that around infinity, we don't use brackets, we use parentheses, right? So we're going back to interval notation. Right? So my domain is saying like any number between negative infinity and infinity is a valid input. I can input any number I want. And then I could generate an output. Okay. But then an easier way to think about it is just look at the graph and try to see how far left did it go and how far right. If it goes to the left forever, then you know that's a negative infinity. If it goes to the right forever, that's a positive infinity. So then that's your interval from negative infinity to positive infinity. All right. What's another way of saying negative infinity to infinity? Do you guys remember? There's like a special symbol or like a certain set of words. Yeah, all real numbers, right? So it's either this kind of fancy looking R, which means all real numbers. And that's great. I'm glad you guys remember that. All real numbers. Because sometimes it's easier just to say that than to have to draw out the infinity symbols, right? So this is a perfectly valid way to describe the domain. All real numbers, right? Use that R. That's what it's for, right? Okay, so domain, and what's nice about absolute value functions is that the domain is always all real numbers, always, because the shape of the graph never has a break in it, right? It slides, right? But it doesn't matter because even if it slides, well, this side still goes to the left forever. This side still goes to the right forever. So you're still always going to be able to have negative infinity to positive infinity as inputs. Okay. So that's one nice thing to remember, is that the domain will never change for absolute value. It's always all real numbers. And that makes it so easy because it's like, well, you don't have to even think about domain. It's all real numbers every time, no matter what. Yes. Mm-hmm. And then there's actually, it's the same for quadratics. And we'll see when we get there. Now the range does change. The range changes depending on the function, because range is not left and right. Range is y values. Range is asking what are the possible y values that the graph has. So there is a finite, it does end somewhere, because take a look at our V shape. Let me erase the highlighted parts right now. Let me see if I can without damaging. Let me see, let me redraw this. Okay, there is a finite level for range, and you want to think about it as like how far down to how far up, right? Y values. Domain was all about x values, so left and right, right? Because the x-axis runs along horizontal, so left and right. Range is y values. Range is vertical, right? Up and down, right? So think about like, what is the lowest y value that we have on this graph? What is the lowest y value? Where is it? Yeah, it's 0, right? It's right here. That's the lowest point that it goes. So my range has a cap. In this case, the range is a minimum, right? I have a minimum because that's the lowest, right? This point actually is a minimum value, right? Because we're looking at the y value. So if my range always has to go from lowest to highest, that's how you want to describe it, lowest to highest. So that's where my interval, that's how I like to think about my interval. What's the lowest? Well, the lowest is 0. Okay. And then the question of like, do I use a bracket or a parenthesis at 0? Well, think about like, do I have a point at 0? And the answer is yes. The point is physically there. Like you could actually like, touch the point. It's right there. So if I can include 0, I put a bracket, right? So the lowest y value was 0. What is the highest y value? And think about this absolute value going upwards. 2 is the one that we plotted, but does it stop there? Remember the arrows, right? The arrows indicate that it moves up forever, so it's going towards positive infinity. Good, right? Moves up forever, so it gets us to infinity, and then you have a parenthesis there. Okay. So really what that indicates is just from 0, including 0, all the way up. So all of the y values that are greater than or equal to 0, those are allowed to be part of the range. If it goes down, then I'll show you how that works. Because if it goes down, I start at my lowest, remember? So at my lowest would be negative infinity, and then I have to find out where is the highest point, right? So it's opening up this way. We'll have to look at it slightly different, but it's still same idea. We probably would use negative infinity. Okay. Now, how is the range slightly different? It can be written differently. We can't use all real numbers, obviously, because you're not talking about all the numbers. You're only going from 0 to infinity, right? So all of the negative numbers aren't there, so you can't use all real numbers. In Desmos, in IXL, it shows the range slightly differently. You'll see something kind of like this, where it's got like these curvy brackets. What it's saying is that the range is the set of y values such that y is greater than or equal to 0. Right? You'll see things like this. So it just means all of the y values such that y is greater than or equal to 0, right? Because you're going from 0 to positive infinity. So these two things mean the same thing. They mean the same. But just kind of like be able to read it both ways, because in IXL, that's how the range will show up, right? It'll show up like what I wrote in green. All right. So you want to be able to think about it as like, okay, if it was an interval, or if it was an inequality, right? What kind of numbers would it show me? Well, okay, 0 and then everything bigger than 0. That's how I know that that's the correct range. All right. Does that make sense? Any questions so far? So remember that domain, you describe it going from left to right, like you're reading a book. Okay. Domain is left to right. Range is lowest to highest. And the reason why I stress that is because every year I always get kids who switch it around. They give me the right to left or highest to lowest. Left to right, lowest to highest. Okay. Or bottom to top. All right. Any questions on that so far? So it's kind of a lot to it, right? It doesn't seem like it on Desmos. It's just like, okay, that's just what it looks like. But this is the part where we kind of start to understand the functions at a deeper level, right? Not just plotting them, but understanding the domain and the range is super important. Okay, being able to read them. All right. Are we good to move on? I'm going to show you another example right now. All right, sounds good. Let's do it. Okay, next example, still pretty easy, pretty straightforward. What I'm going to do this time is we're not going to do the table. I'm going to show you a shortcut, all right? How to graph the V shape without making a table, because there is a nice little pattern that we can use. So function here is f of x is equal to absolute value of x plus 3, okay? I want to identify what the vertex will be first, okay? We always start there. I have my function, identify the vertex, always, okay? So I'm going to look at what's inside my absolute value. I have a positive 3. So am I going to use positive 3, or am I going to use the opposite of positive 3? Opposite, right? So label it right underneath. You can put OPP, right? Opposite. So instead of positive 3, that's a negative 3, right? So your H value is actually negative 3. Okay. Now I want to look for K, but I don't see a number out here, right? So would it be okay to say like I'm adding 0? Yeah, right. So when you don't have a number outside, it's because it's a 0, right? So you can just add 0. Now, how does that help you? Because now you know that that's going to be your K value. So K is going to be 0, right? So there's your vertex, right? So you can see that there was only one transformation that took place, right? It was x plus 3. So that means you actually shifted 3 units left. That's why your vertex is at negative 3. Right? It moved 3 spaces left. The whole thing shifted with it. Right, so we should kind of expect to see the vertex show up on the left side of 0. Okay, so I'm going to go ahead and now I'm going to skip right to being able to draw the graph, because I don't need the table anymore. Right, I'm going to show you the shortcut. Okay, so plot your vertex first, right? That's always what we want to do. So you have -1, -2, -3, right? So at -3, 0, there's my vertex. Here it is. Okay, so label it -3, 0, put a little V next to it so you know that that's your vertex. Okay, now how do we know how to graph this without the table? Okay, well, let me show you something. There's an invisible number outside right now in front of the absolute value, right? We don't see it because it's not there, but typically, what is that number? It's a 1, right? Invisible 1, right? Because 1 times anything doesn't change it. Okay, Now, the 1 also has an invisible denominator, okay? The invisible denominator of 1 is also 1. Now, why do I show you that? Because we're going to treat this 1 over 1 like if it was the slope of the graph. Remember that V is 2 lines, right? Every line has a slope. So we're going to use that to our advantage so that we don't have to make a table every time and spend all that time making it. Instead, we use the number in front. So whatever my A value is, remember that number in front of the absolute value is A. In this case, it wasn't showing us, but it's an invisible 1. And every number has a denominator as well, right? So if it's 1, well, it's 1 over 1, okay? Now, why is that useful? Because 1 over 1 is my rise over my run. So 1 over 1 is the slope. Remember that slope? If it's 1 over 1, that's going to be 1 rise, 1 run. Okay, so check this out. 1 over 1, we're going to go up 1 to the right 1, up 1 to the right 1. Okay, now remember, V is where my symmetry happens. Okay, V is where the symmetry happens. So not only do I go up 1, right 1, up 1, right 1, I'm going to go up 1, left 1, up 1, left 1. I got to follow the slope in the forward direction and then in the backwards direction so that I can capture the full V. All right, so I go up 1, and I'm gonna use a different color now. Up 1, left 1, up 1, left 1 again. Right, so you see the importance of labeling V as the vertex, because I know that that's the point where the 2 lines are gonna meet, right? So I don't wanna like make a mistake and like draw the V somewhere else. I wanna draw it so that they both connect at the V at the very bottom, all right? So then now we can connect starting from V, from vertex, connect your points. Oh, wait, why is it doing that? Hold on. Yeah, let me try that. Am I too close to the left? Maybe I am. I might have to draw it by hand. Okay, let's do that. All right, and there's my V shape, right? Nice and easy, right? We just use slope. Slope from algebra 1, right? Rise over run, we use it. Whatever number is in front of the absolute value, that A value is our slope. So you use it to graph the left side of the V and then the right side of the V as well. Okay, do you guys see that? That's kind of neat, right? I love tricks. Well, not tricks, but. Right, so it saves you a bunch of time. You don't have to make the table. You just know, okay, I look for the slope. The slope will always be the number that is in front. And there is no number, that means it's an invisible 1. And if it's an invisible 1, then it has to have a denominator of 1 as well. So there's my slope, 1 over 1. Slope is rise over run, so go up 1, right 1, up 1, right 1. But to make the other side of the V, you're gonna go up 1, left 1, up 1, left 1. Okay, so it should match. It should be symmetric. It should have that nice V shape. All right. Any questions? Feedback? How was that? You guys like that better than the table? Yeah, it's pretty awesome, right? And then there's a trick for quadratics too. I'm gonna show you that. Okay, so now what's the other, what are the important characteristics for us to identify now? What else must we do? Domain, yep, and range. Good. All right, domain is the easy one, right? How far left? How far right? What can we say about the domain every time we have absolute value? All real numbers. Yep. All real numbers. So you could either tell me it's negative infinity to infinity. You could give me the all real number symbol, or you could literally write it out. Okay, those are all valid ways to say the same thing. Okay, all real numbers because this V also moves to the left forever and to the right forever, right? V shape that keeps opening in both directions. So it covers the entire x-axis. If you zoom out far enough, covers the whole x-axis. Every number can be plugged in. Every number can be plugged in and get an output from that. That's what it means. All right, now the range. The range, remember, range is what? How would we write it as an interval? Okay, if you tell me -3 to positive infinity, you're saying the graph went down to -3? Yeah, it's lowest to highest, right? So you're thinking lowest y value. You have to shift how you see it. Instead of looking at it this way, you gotta look at it this way, right? What is the lowest y value? And this is the tricky part. Yeah, if it's this point right here, what is it on the y-axis? Well, on the y-axis, it's 0, right? So the range is lowest y value is 0. We can get to 0. I can get to this point right here. So it's going to be a bracket 0. And then now I look to see how high does it go. If it keeps going up forever, which it does because of the 2 arrows, then we know, hey, that moves up to positive infinity. Okay. But that's why range is tricky. Why? Because we're so used to reading the x-axis, right? If you're telling me that the range would have been -3 to infinity, then my function would have had to have shifted down 3 units. My v would have had to have gone down all the way to this point. But my graph isn't there, right? Do you guys see why it's not -3 to infinity? Okay, but I'm glad you took that chance because it gives us a chance to talk about it, right? Because it's a common mistake. You're not the only one. I have that happen every year, right? Everybody is in love with looking at the x-axis, but you got to look at it slightly differently, right? Lowest to highest. Lowest is 0. Okay. So then once again, this would probably show up on IXL as curvy brackets, which mean the set. So the set of y values such that y is greater than or equal to 0, right? Because it goes from 0 to infinity, so it's 0 and everything above that, right? So you're likely to see it that way. Typically, we don't use this notation until you get to like college calculus. Not a lot of teachers show it this way, but IXL does, which is strange. So it's just another way of saying the same thing. These two are exactly the same. Right, so both of those are acceptable. I would prefer you give me the interval notation though. It's a little bit cleaner, a little bit easier to write. All right, how we doing? Any questions? Are we okay so far? Ready to move on? Actually getting it. All right, all right. Good to hear, good to hear. Yeah, graphing is fun after you've been doing a bunch of word problems, huh? And then after this unit, you guys are gonna be like, oh, can we stop graphing, please? Like, I'm so done with graphing. All right, let's do another example here. All right, let's try to see a couple transformations, right? How can the vertex change? So we have f of x is equal to negative absolute value of x plus 3 and then plus 2. Okay, what's the first thing we find? Vertex, yes. Vertex, most important point, okay? Remember, vertex is just HK, AKA opposite keep, all right? So go inside the absolute value, highlight that number, Do we want 3 or do we want opposite of -3? I'm sorry. Do we want 3 or do we want the opposite of 3? And we want the opposite, right? Sorry, I gave the answer away. So we want the opposite. Okay, so we're going to go ahead and say, all right, we want opposite of that. We want -3. And then we look to the outside. I see a +2 this time. Do we want to keep it or do we want the opposite of that? Keep, right? K for keep, H for opposite. That's my teacher joke. All right. -3, 2. So that's my vertex now, right? So that means my graph has not only shifted left and right, it's also shifted up. Okay, so it actually moved 3 spaces left and then 2 spaces up. And not only that, there's something else that happened to the function. Right? Can you tell what happened? What's the A value? And what does the negative mean? What do we know about the V shape? Which way is it going to open? Up or down? Yeah, the A value is -1, so it opens down, right? That's the thing to remember, okay? So we're going to use our trick, but the reason why it's good to know that is like, okay, since it's a negative in front, it should be opening down. So you should know that already so that when you graph it, right, you end up graphing it in the correct direction. You don't accidentally graph it pointing upwards because then clearly, right, the negative tells you it should be going downwards. All right, so let's take a look at that. All right, let's go ahead and put the XY plane. Oh man, moved on me. Let me redraw it. It's a little funky. Okay. So vertex first, right? So we go, here's -1, -2, -3, -3, and then up 2. So we're going to have a point right here. That's my vertex. Okay. That's my V, -3, 2. Okay. Now I'm still going to use the slope shortcut. Okay. Now it's a negative, right? It's a negative, but there's still a 1 there. It's a -1. That's the invisible number, right? -1 also has a denominator, right? If you don't see the denominator, it's because the denominator is also an invisible 1. So check it out. That's my slope. So if you need to, write it off to the side. My slope is -1 over 1. That's my rise over my run. Okay? If the slope is saying -1 is the rise, you're going to go down, right? Negative on the slope represents move down 1 unit. So we're going to move down 1 unit, and then we're going to run 1 to the right. And then again, down 1 and 1 to the right. Okay. But then I also need to go in the other direction, right? So it's still going to be 1 down, but now go 1 left. Right. So let me do a different color here. 1 down, 1 left. 1 down, 1 left. And I know I'm kind of off the map here, but that's fine. Okay. So now let's graph. We start from the vertex, connect through the points. Why does it do this? Right there. And then the next side, from the vertex through the points. Make it match. Okay. Easy stuff, right? Not bad. Find your vertex, find the A value. Your A value will be your slope. In this case, it was a negative, so we squeezed the 1 in there, -1. -1 over 1, that's my slope. Go down 1 to the right 1, down 1 to the right 1. And then do it to the left side, down 1 to the left, down 1 to the left. All right. All right, last thing. What is it? What do we need to find? Domain and range. All right, let's do it. Okay. Domain, easy one. What is it? It's all real numbers, right? Negative infinity to positive infinity, okay? Because even though it flipped around, you're still looking at how far left is it going? How far right is it going? Well, it's still moving to the left forever, right? So don't focus on the fact that it's moving down. It's just moving left. And the other side is moving right, okay? So you want to read it just horizontal, right? The direction in which that graph is going, right? To the left. So domain will still be from negative infinity to infinity, or all real numbers. Okay. Now the range, this is the part where it's slightly different. You have to look at it differently because the range is always lowest to highest, right? So 2, is that my lowest or is that my highest? Should it be on the left or should it be on the right? It's the highest, right? So you kind of want to flip yours around a little bit, right? Think about how far down it goes, right? So the lowest, there is no lowest because it keeps going forever towards the bottom. So it's a negative infinity where the interval starts. So it's like you're reading in the graph from bottom to top. So the range is from negative infinity, and then it gets to the highest point this time. Right? And the highest point this time is actually at 2, right? It's at 2. The y value is 2. So we get to 2, and then we stop, right? The graph doesn't continue above 2. So then at 2, we can actually include 2. It's a bracket. Okay. Now, how do you think that would look like on like IXL? You would have all y such that y is what? How do you write an inequality that indicates everything below 2 and including 2? Yeah, right. This time it'd be less than or equal to 2, right? That's what you'll see, right? Because now you're saying, okay, from 2, everything below it. And that's how you would see it. Okay. So that's a pretty good foundation for today to be able to kind of get you started. The slope shortcut works with any number. So if the number would have been 2, that just means rise 2, run 1. If the number is a full-on fraction, like 3/4, you rise 3, run 4, rise 3, run 4, right? So you got to think of that number as a slope. So go back and remember your Algebra 1 days when you're graphing lines. Okay, same idea. Okay, so there are like a couple more, which I'll leave until Thursday. It'll kind of be like a little warm-up for us. And then we'll move on to transformations, describing the transformations, as well as finding the x and y intercepts. Okay, so we'll do that next time, and then we'll be done with absolute value, and then we'll move on to quadratics. Okay, any questions about today? There are 2 IXL homeworks. I will post them shortly. I had them ready, but I forgot to copy them over into this class. Okay, so that'll be the only homework for today. It'll be like 2 quick, easy IXLs. You should be able to do them. No actual physical, like written homework. All right, so just the IXLs. Any questions? I think I had them due by like Friday night, but they're quick. Like you get through them in like 10 minutes each, probably. All right. And if not, I'll be here for tutoring too. So can you show example 2 real quick? It didn't. Okay. In IXL, you'll just click it. It'll give you like I think multiple choice, and you just click the correct one. All right, number 2. Somebody's asking me to review number 2. Okay, so let me kind of go back here. Everybody else, you're free to go. I'm just going to review this for somebody who asked. All right. All right, so let me kind of go backwards here on number 2. Let me erase the parts that I kind of included here. Okay, so did you see how I found the vertex? Does that part make sense? Oh, we just need to copy it. Okay, so you understand it. Okay. All right, I'm glad you clarified that. All right. All right, I'll leave it up so you can copy it. Have a good one, everybody. Take care. I'll see you Friday.